Welcome to the third lesson in our unit on linear relations. By the end of this lesson, we are going to be able to calculate the rate of change, also known as slope, as well as initial values from patterns, tables, and from graphs. So far, we have already talked about how to find the rate of change given patterns and tables, so this should just be review for most of the lesson. But finding the rate of change from a graph is going to be new. Okay, so we're going to do the first 4 examples quite quickly because, as I said, this is review from the first 2 lessons. In the first 2 examples here, in example 1 and example 2, we are given a pattern drawn for us. Figure 1, figure 2, and figure 3. So I'm going to just quickly count how many blocks I have. So I have 7 here, I have 9, and then I have 11. So to find the rate of change, I just see how many blocks I'm adding each time. So I'm adding 2, and then I'm adding 2. So the rate of change, also known as slope, is found by seeing how many blocks your pattern is increasing or decreasing by. So the key words being used here is rate of change and slope so far, and those mean the same thing. So what I'm going to do is say that my slope, or my rate of change, is positive 2. The initial value is found by seeing what figure 0 would be. So if I was to start before figure 1, how many blocks would I have, or how many tiles would I have? So in this case, because I'm adding 2 each time, I would have 5. Because 5 plus my rate of change of 2 will give me 7, which is what's given in the problem to begin with. So my initial value is 5. In example 2, again, I'm going to count how many blocks I have in each figure. So figure 1, figure 2, and figure 3. And I say I have 13 tiles or blocks, 9, and then 5. So this is a decreasing linear relation because I am losing 4 blocks, so it's minus 4 each time. So my slope, or my rate of change, is minus 4. My initial value is found by finding out how many tiles I would have in figure 0. Because I'm losing 4 each time, that means I would have had to start off with 17 tiles, because 17 minus 4 gives me 13. So to keep this pattern going, I would have had to start from 17 tiles. So my slope is minus 4 here, and my initial value is 17. Next, I'm going to find the initial value and the rate of change from tables. So in this problem, I have my x values, which increase by 1, 1, 2, 3, 4, and my y values that are given to me. I have room to find the first differences, so it's just the second take away the first. So 9 take away 7, which is 2, and then here it's 11 take away 9, which is also 2, and then finally 13 take away 11, which is 2 again. And you can see that you're increasing by 2 each time, so 2 looks good. And therefore, my slope is just 2. Now, this is only the case because our x values are increasing by 1, that our first differences is the same as the slope. If the x values were increasing by anything other than 1, I would have to do another step to find the slope given the first differences. And we're going to look at that in a future lesson. The initial value would be, what would the table start from if it started at 0? And because we're increasing by 2, it would have to start at 5. Because 5 plus 2 is 7. So my initial value is 5. In example 4, again I have a table, And if you look, my x values are increasing by 1, and this time my y values are decreasing. So my first differences should be negative. First I'm going to do 5 take away 10, which is minus 5, and then 0 take away 5, which is negative 5, and finally negative 5 take away 0, which is negative 5. I am losing 5 each time, so negative 5 works. And again, because my x values are going up by 1s, my slope is simply negative 5. To get the initial value, I need to see what the table would be if my x value was 0. So what would I have to start from for when I take away 5, I end up at 10? I would have to start at 15. So in this table, my slope is minus 5, and my initial value is 15. In the next two examples, we are going to find the initial value and the rate of change given graphs. So this is new. This part we have not seen before. So what we are going to do is find two nice points on the graph. And when I say nice, I mean we want the point to go right through the two lines, like the cross of two lines. We don't want to find a point like this one, which is in the middle of the two lines. So in this example, one point's drawn for us, this point here, and another point up here. And what I'm going to do is underneath the line, I'm going to draw a triangle connecting those 2 points. And then what I'm going to do is find something called the rise and the run. The rise is how far up or down I have to go between the 2 points, and the run is how far over I have to go between the 2 points. Because I've drawn the triangle, I now simply have to count the squares. I go over 1, 2 squares. So the run is 2, and I'm going to the right, so it's positive 2, and then I'm going up 1, 2, 3, 4, 5, 6. So the rise is positive 6. Up means positive, to the right means positive. So to find the slope, what I do is I find the rise over the run. Here we said the rise is 6 and the run is 2. So I have to do 6 divided by 2. If possible, I will simplify this fraction. If not possible, I will leave it as a fraction. But 2 goes into 6 3 times, so I can simplify this fraction to 3. So the slope of this line, of this linear relation, is 3, because I did the rise divided by the run. Now this only works, counting the squares, when your scale goes up by 1. Just like in the last example, the x values in the tables only went up by 1. And again, we'll see what happens in a future lesson when this is not the case. And now to find the initial value, we simply look to see where the graph meets the y-axis. So here it crosses the y-axis at 1. So we know the initial value of the graph is 1. I'm going to write down a quick explanation of how I found these values in the right column. Okay, so for the slope, you make a triangle to find the rise and the run. Then you use slope equals rise divided by run. One thing I should say is if you get your signs wrong when you're finding your rise and your run, you can look at your graph and see that your graph is increasing, which means that the rate of change is positive, which means that the slope is positive. So our answer of positive 3 looks correct. And then to find the initial value, you find where the graph crosses the y-axis. So let's do this next one. We see the 2 points indicated, which is not always going to be the case, but you can see that this point is good because it crosses the 2 lines. It's in the middle of where those 2 lines cross. And same with this point. You could use another point on the graph and you should find the same slope. Draw a triangle. And starting from the point on the left, we have to go down 3 squares. So going down 3 means I'm going negative 3. Down means negative. So your rise is negative. And then my run is to the right by 4, so it's positive 4. So to find my slope, it's rise divided by run. My rise was negative 3, and my run is 4. I cannot simplify this fraction. 4 does not go into 3, so I leave it as a fraction. And if you look, my slope is negative, and that makes sense because I'm decreasing. If you miss this negative on the rise and you just put 3 here, and you got 3 over 4, just put the negative in front because you know your slope should be negative because the function or the relation is decreasing. The line is decreasing. And the initial value of this graph, we're going to see where the graph crosses the y-axis, which is right here at 7. So the initial value of this graph is 7. And that is all of the learning goals for this lesson.